Hi, I'm Aji.
Hi, I'm Alan.
Today we are going to discuss how to build AI powered food calorie counting app which can snap or upload a photo and provide calorie estimate. We will be comparing accuracy of the app by using two different language models, Google Gemma 3 model and OpenAI GPT 4o. We will also be discussing the impact of the model size and what a parameter is to the model. Let us see the demo of the app.
So, we are going to see the demo of a calorie calculator app. This demo is based on the locally hosted Gemma model. This is the screen that we have built to see the model performance. It's very simple. You can click here to upload and then click submit. Over here, the calories will be displayed. So let me click here to upload. I have pre-selected an image. This is an image that I have captured using my phone and uploaded to my computer. This is an image of a food that we had made at home. Once I hit submit, the app will display the calories here. So as you can see, the nutritional information has been displayed. It has identified the food as chicken with sauce, French fries, broccoli, but some of the food has not been identified, like the noodles here, and the total calories also has been calculated, and it gave us a disclaimer also.
So that's an interesting demo. And I would like to know what is the technical architecture and how actually the app determine calories from the photo of a food.
So let's do a little bit of a code walkthrough to see how this app works. This is similar to the app that we had shown earlier, only 50 plus lines of code. So the technology that we are using are Gradio, Base 64, and Olama, right? These are the one. And the
Yeah.
model that we are using is Gemma 3, 4 billion parameters. Okay. And then in addition to that, we use the Python imaging library, which is indirectly used by Gradio. As you can see, we are given the image processing called PIL. This is the Python imaging library. So these are the technologies that we are using in this app. Now, to come to the code, I showed you the demo already. So in that demo, the screen that was built has image input that is very easily built using this particular one line of code. Image input is equal to Gradio image type PIL upload, and the label is upload image. That's it. And then you build the whole interface by passing the parameters to the Gradio interface function. Here you can see you give a theme, description, a title, and the outputs is you have the Gradio HTML calories information, right? That's it. And you give the inputs as an image input here to the interface. So that's how the particular thing gets connected to the input. Now, when you click on submit, this function get calories is called, and that's where the whole calculation happens. Okay, so in this get calories, you first convert the image to a buffered base 64 encoded value, because that is what the Gemma model expects. So in order to for us to do the image to calorie conversion, what we have to do is we have to give a prompt to the model. So here, as you can see, we are building the text prompt, which is name of each food in the image, calculate the calorie for each food. We are giving pretty much plain English language instructions one by one, line by line. And as you will see, when you build this, you will have to tweak this prompt to get better results, right? So this is like a demo that we have built. So we have minimal amount of prompts here. And after building the prompt, you can see that if you have seen the previous demo, you see that Aji had done the demo and he had hosted the Olama on his local machine. In this case, I'm hosting my Olama on a Mac Mini, which is actually within my network, but still it's remote. It's a different computer. So this is the IP address of internal IP. I don't care. I'm sharing with this. Nobody should be able to access it. But usually the port is 11434. So you can host it on a server that you have at home if you have a powerful enough machine, and then connect it from your laptop so that you don't have to have a powerful laptop to work with. Then all you have to do is call the Olama client.chat, pass the model name, and as you can see, we are using the Gemma 3 4B for the demo, and this is why I'm walking through with this. And here you are telling the system what it is, right? You are an AI assistant that can analyze images and generate what food it contains, how many calories, and display it in a HTML table format, right? That's what we are doing here. And also, you're passing the prompt that you just built, which I just walked you through the plain English prompt, and you're passing the images. In the tag, you're sending the base 64 image. Now, Google Gemma is a multimodal. So because of that, it's able to interpret the values based on the image and text. That is how we are able to convert and display the results related to the calories. And from here, it's very simple. You just go to the response and key it by message and content and return the value. That's it, right? That's all the code is there.
Yes. So the key difference here compared to the previous demo is you are running the model on a different machine.
Yes.
And earlier I was running on my laptop itself. I am interested to know how Gemma model performance, analyzing and estimating the calorie from the photo.
A lot of data on the internet and wherever it found the data from, so that is how it's able to calculate the calories, right? So it has
Yeah.
information that is fed into it and it is trained to do that. Now, as you can see in the demo, it did not recognize all the food, so the accuracy of this is not as good as if you were to do it using some other models that have trillions of parameters, such as OpenAI hosted ones, right? So maybe we can look at that for a bit.
You mentioned some of the food items were missing in the calorie estimation. Can I see it?
Yeah, let's look at it. So you can see that in this particular image recognition, it did not recognize the noodles that are here, right? We can try to see if we use a different model, whether it will recognize that, right?
Of course, yeah. Let us try with a bigger model. So, are you
Yeah.
going to use a bigger Gemma 3 model?
No, I'm trying to use a hosted model because I don't think I can run that big of a model on my local. So we'll try to use OpenAI's API. Right, instead of
Yep.
actually hosting it on my machine.
Let's
Okay.
do that. Yep.
Okay. So now we are going to look at the demo of the food calorie calculator using OpenAI. Right. We are going to make a API call to OpenAI. Here I'll upload the image. This is an image that I had used in the previous walkthrough. This is the same food, and I've put a comment here saying that the results will be displayed here. And once I hit submit, it will process the image. We are not using any food calorie database or anything. We are entirely relying on the model. Okay.
Oh,
As you can see, the OpenAI model has identified the food: ramen noodles with sauce, fried chicken, fried onion rings, grilled broccoli, sauce dip, and it has calculated the total calories. The OpenAI was able to calculate this much more accurately than the Google Gemma model that I hosted locally because of the number of parameters it has, right? It is, I think, 1.7 trillion parameters versus the billion parameters that we have hosted locally.
OpenAI model is a bigger model with 1.7 trillion parameters. So that's why it is able to recognize wide variety of food items. So do you think the Gemma bigger model, Gemma has bigger models, right? So if we
Yeah,
use one of the Gemma bigger model,
yeah.
would that be better performance also?
I'm pretty sure. Yeah, yeah.
But we can't run it on local PC
We
because
cannot run it on my local PC because of the size. Yeah.
so we saw that the bigger model performed well in this use case. Choosing the model, the size of the model depends on the use case, right? I mean, you don't need to have always use a bigger model.
Yeah, I have personally used a smaller model for example, code generation, and in that case, the smaller model was sufficient for me.
So I have two questions. One is, how do I know a model is big or small? And you said about 4 billion parameters or 1.7 trillion parameters. So what is a parameter in a model?
Yeah, that's a very good question. So first, let me walk you through the code for the OpenAI call. Right, as you can see, This is also just 50, 60 lines of code. Yeah, we are importing the OpenAI to actually make a call to the OpenAI client. You're creating a client for OpenAI.OpenAI, and then you're using that client to communicate with the GPT-4o model. Before you do this, we have to create a token which is needed to communicate with the API, obviously because it's a hosted one. I have a open API key. That's the prompt and everything is still the same. And here you're saying dot OpenAI API key equal to OpenAI. You create a client and then you call the client.chat completions.create and GPT-4o, right? The model is GPT-4o and everything else is the same. Okay. So you're just passing the image using base64 image URL f data image. It's slightly different than the how you pass it to the local Gemma model using Olama, right? And you also give the max tokens as 300 so that it doesn't keep on generating too many things. Apart from that, everything else is the same. The only slight difference is that the image URL when we are passing has a slightly different syntax than the Gemma one. And the response or choice is zero message dot content also. The Gradio interface, everything else is the same. Now you asked me, Aji, about how do you know the parameter size? Whoever created the model will tell you how many parameters they have. I want to go back to the Gemma 3 model. So here it says Gemma 3 4B. This kind of indicates the 4 billion parameters, right? It has 4 billion parameters. And here in GPT-4o, you're not specifying the number of parameters or anything. It's not exactly published. So you can only approximate. People say that it has 1.7 trillion parameters, right? And to come to what a parameter is, I've created a small diagram. We don't have to get it complicated into algebra, but let's say you're writing a Python function y1 equal to b plus w1 x1 w2 x2 w3 x3. And if I were to represent it using a diagram, it would look like this. X1 is an input, x2 is an input, x3 is an input, and each of these lines carry a weight w1 w2 w3, and there's a bias that is added to it, and you get the output y1, right? So in this case, this is not even a proper model, but it's just an equation. It has 4 parameters, right? You have b is bias, w1 w2 w3 are weights, and b is a bias. So you have 3 weights and 1 bias, which is 4 parameters. Now let's look at a slightly complex one. I'm not going to go into depth on this, but if I were to add a hidden layer into this is the smallest possible neural network, which is also known as a perceptron. In this case, you have 3 inputs, x1, x2, and x3. And as you can see, I have numbered the weights that go from each of this input into the hidden layer and from the hidden layer to the output, right? You can count it if you want. I'll share this image also with you, but there are w1 w2 w3 w4 going from x1, w5 w6 w7 w8 going from x2 to these hidden layer, and like that, right? So totally there are around 16 of these weights, and each of these has biases 1 2 3 4 and 5. So 16 plus 5 is 21, right? So you have 21 total parameters for the simple model. Now imagine a model with 4 billion, 2 billion, or 7.7 trillion. You can imagine the size of such a model. It is very huge. So this is what a parameter means in a model.
That is what I was trying to visualize. How will it look like when I visualize a 4 billion parameters on the on the screen? And that's very interesting to know that. So more parameters, so the processing is more, and you need a bigger infrastructure to run the model, right?
Exactly.
Okay. So
Like when you have a simple equation, you can only capture linear relations between the input and the output. As you get more models, you can the relations you can capture are more complex. So you can capture non-linear things. Like if you were to use a handwriting recognition tool, in that case, if you have a smaller number of parameters, maybe it will recognize the printed ones or very, very nicely written handwriting. But if you have a more complex model with more parameters, it can maybe recognize poorly written handwriting.
now I understood why the noodle is missing in a smaller model. So that was an interesting walkthrough, Alan. So we will be sharing the source code of the demo in GitHub. See the link in the video description. I think the video was helpful. If you want to watch more videos Subscribe the channel and share with your friends.
I hope we can come again with another video soon. Thank you, everyone. Bye.